All right, guys, welcome to Inscribed Angles. It's a lovely Friday evening here at the school while I'm working on this. I hope you guys are enjoying this. Maybe you get a little bit of look at this on the weekend. Try to have everything ready. These are due on 4/10, okay, along with the rest of the packet on 4/10. Most of the angle stuff will be due on 4/10. So we talked today in the notes and yesterday about inscribed angles. All right, so inscribed angles are angles that are, hold on, put my glasses down here. So inscribed angles are angles that have the vertex of the angle on the circle, So it says, is this an inscribed angle? The answer is yes. If it is, then name the angle in the incepted arc. If it's not, then don't worry about it. So this one over here, number 2, that vertex is not on the circle, so you can just put a no over here. All right? And you don't have to name anything because it said no. So for yes, it says name the angle. The inscribed angle is CAB or BAC. So that's angle BAC. And then the incepted arc is going to be the arc made by that angle, which is this arc right here. Takes the shortest path, and its name is arc BC. And there we are. Guys, these are really simple and easy. If it's a no, then you don't have to worry about it. Name this one, put the angle, move on. Okay, so for number 5, find the measure of the arc or the angle indicated. All right, so basically, arc equals twice the angle. Okay, and that comes from the idea that we talked about. It's going to be the sum of the two arcs, or the two arcs are going to be averaged to give you the angle. But one of these arcs is non-existent over here. So this is going to be 80 plus 0 divided by 2. So really it's just 80 divided by 2. And so that tells me that this is going to be 40 degrees. Okay. But now what if I have to go backwards? What if they've given me the angle and I need to find the arc? So the same thing happens though. These two arcs, so this WX and the one that's non-existent, have to add to be the average, be 42. So we just said it was going to be the arc divided by 2 gives you the angle, or the arc equals 2 times the angle. So the arc is going to be x. That's equal to 2 times the angle. And the angle in this case is 42 degrees. All right, so that really means that measure of arc WV is equal to twice 42 degrees, which is 84 degrees. All right. Back on. I'm going to zoom out just a little bit. Okay. And let's move over to some of these more difficult ones. This is quite an interesting one, a little bit difficult. You had to figure out that the 35 was in this corner. That means that its arc is over here. And remember, we said the arc equals 2 times the angle. Well, if the angle is 35, then that means this arc is 70 degrees. Now, also, don't forget about FD here being a diameter. Means it cuts the circle in half. That means it also cuts the arc measure in half. So 360 divided by 2 means this is 180 degrees. So what does that leave here? Well, it's 180 minus 70, so this is 110 degrees for P to D. Arc PD. All right. Right here we have a triangle. 3 angles inside a triangle, so you need to find this angle right here, measure of angle DBC, and then you're going to use that to figure out what arc, the measure of arc DC is. Okay. Now let's go to page 2, the back of this, and we start getting some really interesting things happening here. So let's start at looking what is the incepted arc. So if I take, for instance, this 119 degrees angle here, what arc is it incepting? Well, it's going from F to H, but it's going the long way. So it's really incepting arc FGH. Okay, so measure of arc FGH is equal to twice 2 times 119. That's going to be, see, 2 times 100 is 200, 2 times 10 is 20, 2 times 9 is 18, so that's 238 degrees. So this is 238 degrees in total here. But this section from here to here is 168. So that means that I can find this section by subtracting it. 238 minus 168 gives me this. So that is, let's see, 238 minus 8 is 230 minus 160, so it's 130 minus 60 is going to be, what, 70 degrees? So there's 70 degrees there. And some of this might be overkill. I probably could have found some of the rest of this another way, but I'm just being diligent here, doing my due diligence. So if I look at 65, it's really going from V over to G, okay? So that's this arc. And 65 times 2 is going to be, what, 130 degrees? So the black arc is 130. Take away this 70. That means that the green arc here, F of V, has to be 130 minus 70, which is 60 degrees. So measure of FV equals 60 degrees. Okay, might as well go ahead and throw the rest of them down here while I'm at it. Measure of FG equals 70 degrees. And let's see, we already had GH is 168. So let's figure out what VH is. We pretty much just need to add in. Let's see, if red is 238 and this is 60 more, so that's 298, then what does VH have to be? It has to be 360 minus 298, so that's going to be 62 degrees. From there to there. Okay, so I want to try to figure some of these things out. Like, for instance, what is this corner here? What is this corner going to be? Well, it goes from F to H. And from F to H is going to cross a 60 degree and then a 62 degree. So that's going to be, did I make a mistake somewhere? Well, this says it's 100. Oh, that divide by 2. That's what's the problem with my head right now. I'm like, what's going on? So 60 plus 62 is 112, but I got to divide that by 2. So 112 divided by 2 is going to be 61 degrees. Man, Mr. Conaway, too long of a day. Okay, and then if I want to find this other angle, let's say this one, I'm looking at going from G to V, the other direction. Well, you know, I could add those together. That's one possibility. Or I could say, look, this is 130 this way, so the reflex angle is going to be 360 minus 130. Well, 360 minus 100 is 260. Minus 30 is 230. So this is going to be 230 degrees around this edge. Cut that in half, and I'm going to get half of 200 is 100. Half of 30 is 15. 115 degrees. Okay, now the reason why I wanted you to see this is because there's a special relationship here. Look at these four numbers and see if you could pause it and see if you can find the relationship before I tell you. Okay, so let's look at the relationship. What do you notice about these two and those two? So what do you notice about those two and the red two? Well, 115 plus 65 and 119 plus 61 both come out to be 180. So that's an actual interesting little tidbit about any time you have a circle. Well, that's not really a circle, but, you know, whatever. Mr. Conaway's not perfect. I know. I look like I am. I act like I am. But I'm not. I'm sorry, guys, to let you down. But Mr. Conaway's not perfect. But anytime you draw a circle around a four-sided object, the opposite sides are going to add to be 180. The opposite angles. That would be the same for these opposite angles as well. Okay? So, that might help you out down here. And now, if we think about it, does that make sense? Well, let's look at this one really quick. Opposite angles, like 110 and this angle R over here, they intersect opposite arcs. So the R intercepts this arc going from here to here. And the P intercepts this arc going from here all the way around to here. What do those two arcs go together to make? 360, right. A full circle. So, and we know that we've been using this whole idea that the angle is half of the arc. So, if I could add these two arcs together to get 360, then when I add the two angles, they should get half of that, which is 180. That's why this makes sense, because they go together to make a full circle, but since they're inscribed angles, they are going to be half of that. Okay, so how does that help me? Well, if this is 110, I know that this is 220. I also know that these two are going to add to be 180, so this is going to make this 70 degrees, and this is going to be 140 degrees over here. Let's see. What am I looking for? Probably this 30x here. So if I have 140 from here to here, take away the 50 for this little section here, okay, then that means I'm going to have 90. PQ is equal to 90. So PQ measure equals 90 degrees. But you know what PQ also equals? Well, somebody wrote it in there for us. It also equals 30x. And you remember that substitution property? These two are both the same thing, so I can substitute them out. And I can say, well, then 90 has to equal 30x. Divide both sides by 30, and I get x equals 30 degrees. Okay. Don't forget to use our handy-dandy little quadrilateral inside of a circle 180 rules. You've got 3 of them down here that you can use it on. Okay, you guys vote. Tell me which one you want me to work, 13, 14, 15, or 16. Everybody who wants 13, raise your hand. Okay, 14. Not too many people. 15? Yeah, that's what I thought. Everybody wants 15. 16, you guys probably like that one just as much. So we'll do 15 together. That's okay. I understand. It looks a little scary. Okay, so if we look at this, X in M is based off of this angle L. So that means this whole thing is equal to 20x because it's going to be double that. Okay. And then I also have this green one that's going to be twice this, so 2 times 16y plus 6, whatever that is. And hey, I could add these to be 360. I could, but x and y. And you and I have talked about when we don't want to put two variables into one problem because it's just going to make it more difficult. So we need to find something where we can put x with x. Okay. So let's take a look at maybe using a different corner. What about this one? Well, this one's going to go from L all the way over here to N. And from L to N, that's going to be 2 times 10x minus 6. And going the other direction, I'm going to get in purple 2 times 4 plus 18y. Oh dear. So, you guys remember that time that I told you don't ever put two letters in the same problem unless you really want to make it more difficult? Guess what? Yeah, we're going to make this more difficult. Unfortunately, there's no diameters here. There are no vertical angles here. There are no congruent angles here. There's nothing that is on the little list. I don't know if I showed you guys all this list, but if you haven't seen this list, you should pause this and write this down. Here are some of the quick things to look for: diameters, vertical angles, sum of parts, and congruent angles. So the only thing I have here is sum of parts. And my sum of parts says this: red and green add to be a circle, 360. Great. And blue and purple add to be a circle, 360. Great. So now I can put these together as two equations. So let's take a look at what we've got. 20x plus this thing is going to add to be 360. 20x plus 2 times 16y plus 6 equals 360. The other equation I'm going to have is the purple and blue add to be 360. So I'm going to get 2 times 10x minus 6 plus 2 times 4 plus 18y equals 360. Okay, so this is going to be fun. Let's go ahead and distribute here. 20x plus 32y plus 12 equals 360. Subtract 12 from both sides. 20x plus 32y equals, let's see, that's going to be 350, 348. Okay. Now, just for the sake of, I really don't want to have to deal with big numbers, I'm going to divide the common numbers on both sides. I know 4 goes into 20, 4 goes into 32. I think 4 goes into 348. So I'm going to just go ahead and do that in my calculator. I'm going to say, look, 348 divided by 4 goes 87. Okay. So I can say that this is going to be 5x plus 4 times 8y equals 87. That's gonna at least make this a little simpler for me. Over here, I'm going to get 20x minus 12 plus 8 plus 2 times 18 is 36. Y equals 360 degrees. Okay, so put these together. Negative 12 and a positive 8 is going to be negative 4. Ah, darn it. Plus 36y equals 360. Okay, so add 4 to both sides. I'm going to get 20x plus 36y equals 364. And I once again think that 4 is going to go into all of these. So I'm going to do 364 divided by 4. And that's going to be 91. So I'm going to get divide 4 into this, divide 4 into this, equals 91. So I've got 5x plus 8y equals 87, and 5x plus 9y equals 91. So you know what? What if I just look at, there's a couple different ways to solve these. And if I solve one of these for something and then plug it into the others, well, take a look at this. I could solve for 5x, and it's already over here, and I could plug it in. So let me just move this 9y to the other side. And I'm going to get that, and I'm going to move over here. 5x equals 91 minus 9y. So let's move up top here, and I'm going to plug that in. So instead of 5x here, I'm going to put a parentheses, plus 8y equals 87. So this is this equation, something plus 8y equals 87. But instead of 5x, I'm going to put what 5x equals. 5x equals 91 minus 9y. Okay, so now putting those together, I'm going to get 91. A negative 9 and a positive 8 is going to make a negative 1y. Subtract 91 from both sides. I'm getting negative y equals, let's see, 87 minus 91. That's a difference of 4, I believe. Negative y equals 4. So, sorry, negative 4, because 91 was going to be the negative one, right? Negative 91. Bam. So now I can divide both sides by negative 1. I get y equals 4. Okay, I got y. Now I need to plug it in to find x. So pick any of this and plug it in, and you'll find x. So I'm going to use 5x plus 8 times 4 equals 87. And so 5x plus 32 equals 87. So 5x equals, when I subtract 32 from both sides, that's going to be 7 minus 2, and 8 minus 3 is going to be 55. X equals 11. All right. Remember what I said about not putting x's and y's together, the same problem, unless, like today, it was our only option. Great. Good luck with number 16. It will be very similar. Okay, so you're going to have to set these up, and you're going to have two equations with two unknowns, and you're going to have to use either substitution, elimination. We use substitution here. We solve for one and substitute into the other. You could also use elimination. I don't know if you remember that one. That's where you put these above each other. That would have worked really well, too. I could have put 5x plus 9y equals 91 and then subtracted them. You remember how to do that? And then these two would cancel, and I'd have got 17y equals whatever those go together to be. That's another way to do it. That's called the elimination method, or the linear combinations method, or the terminator method, as I've heard some people call it. Okay, that is a 24-minute video on the inscribed angles.